right, so we're going to work through an example using an ordinary annuity formula. So as we're looking at this one, our ordinary annuity formula, we're going to start with A. A is our accumulated amount. P is the amount of each payment. Again, R is still our interest rate. T is still our time. N is our number of compoundings per year. Notice that this looks kind of related to some of our other formulas that we've seen, just not exactly the same. So it does have a lot of parentheses. There's a calculator tip down at the bottom of this page, which we'll talk a little bit about. And then kind of, again, as you're working through these problems, make sure you're plugging stuff in and make sure that you are getting the same answers that I am when you're using your calculator. So use the ordinary annuity formula to determine the following. Bill and Megan are depositing $250 each quarter in an ordinary annuity that pays 4% interest compounded quarterly. Determine the accumulated amount in this annuity after 35 years. All right, so P is the amount of each payment. Right, so again, it's not our principal at the beginning. In this case, it's the amount of each payment that's invested. R, our interest rate. As a decimal, 4%, 0.04. T is our time. We are looking at 35 years. And N, we're compounded quarterly, so we're going to have N equals 4. So now we're going to use our formula from up above. So A equals parenthesis, P outside of the parenthesis, and then inside another parenthesis, 1 plus R over N to the N times T minus 1 all over R over N. So we're going to plug all this information in where it's supposed to be. All right, so P 250. All right, parenthesis, 1 plus 0.04 divided by 4 to the N times T, 4 times 35, minus 1, all over 0.04 divided by 4. All right, so we're going to plug this into our calculator. Down at the bottom are some hints for calculator help. Again, as we did in previous examples, we almost want to think about our entire numerator in parentheses. So we're going to add kind of an extra set of parentheses around that. So we start with our parentheses, 250. You can put the time sign in there, you can leave it out. 1 plus 0.04 divided by 4. Use our y to the x or our caret exponent button. 4 times 35. Again, if you wish to do that multiplication just to make it easier, then you can just, 4 times 35 gives us 140. We could replace that part of our formula with 140 if you prefer. Again, make sure we close off all of our parentheses and make sure we get our denominator in parentheses as well. And this is going to give us 7,567.48042. So this is going to give us an amount accumulated. We're going to round this off. $75,677.48. So now one of the things to kind of think about is if we're thinking about the ordinary annuities and if we were comparing this to something where we weren't accumulating interest. Right? So the idea with the ordinary annuities is that we're getting interest on our interest and we're helping build our money. So just for a quick comparison's sake, I'm going to make a little note in here. We'll just use green. So note. If they were not receiving any interest, So let's say instead of investing money in an ordinary annuity, they were just putting it in a bank account that doesn't gain interest. $250 payments times 4 payments per year times 35 years is only $35,000. Right? So out of the money that they have in their account, $35,000 is what they invested, right? And then the rest of it is all interest. So just kind of something to keep in mind, again, as we're thinking about real life applications. If we can make investments that are we're gaining interest, money from interest on, then generally that is going to be something that we're going to want to try to do when it's available.